Good morning everyone. My name is Manoj Kumar. Today in this video lecture we will learn about the minimum spanning tree in data structure. So at first we will see the basic concept of minimum spanning tree. What is spanning tree and what is minimum spanning tree and what are the main applications of the minimum spanning tree. After that we will see how can we find the minimum spanning tree for a given graph or for a given network problem with the help of Prim's algorithm and the Kruskal algorithm. There are two algorithms which are used to find the minimum spanning tree for a given weighted graph. So, to understand the concept of minimum spanning tree, at first we have to need to understand the situations or problem in which situation the concept of minimum spanning tree will exist. So, in case of minimum spanning tree, there is suppose a weighted graph is given. For example, this is a weighted graph, or we can also relate it with a networking problem. There are some kind of nodes or some kind of devices and they are connected with each other. So, suppose this is a graph corresponding to a network, and every node in the graph has a particular edge. Nodes are connected through the edge, and this is the weight of every edge, or you can say that this is also the cost of the edge. Okay. So, this is a problem in which these are the vertices of the graph and these are the edges of the graph, and every edge is a weighted edge, has a specific integer value. Now, our objective is to find a minimum spanning tree. So, what is spanning tree? Actually, spanning tree for a given graph is a tree which consists all the vertices of that particular graph. Main difference between the graph and tree is that graph may contain a closed cycle. Like for this graph, there is a closed cycle, there is a closed cycle, there is a closed cycle. But in case of tree, there will not be any cycle. Okay. So, every graph has a tree. So, for this graph, we have to find a tree which consists all the vertices of the graph and there will be no cycle. So, that tree is known as the spanning tree. Now, what is minimum spanning tree? If we assign the weight for each edge, or suppose if the graph is the weighted graph, then minimum spanning tree is a spanning tree which consists the minimum cost or which consists the minimum weight. It means suppose this graph is given. Now, there may be more than one possible spanning tree. Suppose there are 4 spanning tree. Then among the 4 spanning tree, the spanning tree which will have the minimum weight, that will be act as the minimum spanning tree for the given graph. And again, there may be more than one minimum spanning tree also possible. It means the spanning tree which has the minimum weight, and also they are more than one. Okay. So, this is the concept of the spanning tree. Spanning tree is basically corresponding to a given graph which consists all the vertices, and minimum spanning tree used in several applications, like it is used in network, and it is also used in electrical network to find the cost, or it is also used in water supply network to find the how much cost it will consist. Okay. So, we have to select a spanning tree which consists the minimum weight. This is our objective, and to find the minimum spanning tree, two algorithms are used, Kruskal algorithm and the Prim's algorithm. So, this is the graph, and given a problem, what is the problem? As I already told, that given a connected weighted graph with non-negative weight on the edge, and we have to find a tree for which the sum of weights on the edges in tree is as small as possible. So, what is the weight of edge? So, weight of the graph. Weight of the graph is suppose this is a given graph. Then weight of what will be the weight of minimum spanning tree. So, weight of minimum spanning tree will be the sum of weight of all the edges which are included in that minimum spanning tree. Okay. So, let us understand the first algorithm, Kruskal algorithm. Suppose we have to given this graph. Now, we have to find the minimum spanning tree with the help of Kruskal algorithm. So, Kruskal algorithm is generally used to find the minimum spanning tree for a given weighted graph. Okay. So, to find the minimum spanning tree, the first step is sort the edges by weight. It means suppose this is a graph, then at first we have to sort all the edges in order to their weight in increasing order. Like for example, here This is an age 1 and 6, weight 54, and this 47, 87 and 23. Okay, this weight is our 80, 23, 47, 54. So at first what we will do, we will sort all the ages, and at first we have select the age with minimum weight. So when we select the age with minimum weight, so first this age will be selected, which connect the vertex number 5 and vertex number 2, because among all the ages this age has the minimum weight. So in the starting this age is selected. Now again, after this, what next is which considers the minimum age among the remaining ages. So that is the age number which connect to the node 4 and node 8, and the weight of that age is 29. So this age will be included in is minimum spanning tree. This age will also be included in minimum spanning tree. The ages which color is red, that will included in the minimum spanning tree. Okay, so now the main concept of the Kruskal algorithm is that it is not necessary that the tree is formed in a connected manner. Like here, this is a separate age, this is a separated, and this age is not connected to this age. This is sometimes the students may confuse in Kruskal algorithms and Prim's algorithm. So we will see the Prim's algorithm later. In case of Prim's algorithm, the tree is formed in a connected manner. Like next age will be connected to the previous age. Whereas in case of Kruskal algorithm, this is not compulsory. This is age which connect to 3 and 5. This is age which connect to 4 and 8. And these age are not connected now. But in the last, there may be a connection. Okay. So this it is necessary to tell because most of time student confuse in Kruskal in the difference of Kruskal and Prim's algorithm. Okay. In case of Prim's algorithm, the tree will always be constructed in a connected manner. It means the next age will be connected to any previous age, okay, which is included in the spanning tree. Now, after this, we will select the next minimum weight. So, ages. So, next minimum will be the 31. So, this age will be included. It is shown in red color. So, now this age will be included in minimum spanning tree. Now, again, we will select the next minimum age, weight age. So, this has 74, 54, 75, 88, 47, 80, 32. So, next minimum is 32. So, this age will be connected. Age which connect to the node 5 and node 2. So, this particular age will be included in minimum spanning tree. So, this is minimum spanning tree. Again, what is the main condition of minimum spanning tree? It will consist all the vertices of the graph and must have the minimum weight. Okay. So, now after 32, we will see the next minimum weighted age. So, next minimum weighted age, this is 74, 80, 75, 54, 47, 80, 93, 60. So, I think 47 is the next minimum weighted age. So, 47 which connect to node 1 and node 3, that will be connected, that will be included to the spanning tree. So, this will included in the spanning tree. Now, again, these three vertices are all remaining. Okay, so now we will select the next minimum weighted age. So, this is 54, 75, 74, 88, 55, 93. So, I think next 54 will be selected, the age which connect to the node 1 and node 6. So, this will be included in the minimum spanning tree. Again, two vertices are remaining, vertex number 7 and vertex number 8. So, we will select the next minimum weighted age. After 45, after 54, the next minimum weighted is 85. But we will not select it because if we select the 85, then it form a cycle. Okay. So, again, this is important to tell that when we select the minimum weighted age and we will add that minimum weighted age to the existing spanning tree, and if it form a cycle, then that particular age will not be considered. We will reject it and we will select the next minimum weighted age. So, this will not be considered after 50, this is shown in below, it means it will not be considered, it will not be included in the minimum spanning tree, so it will be rejected. Next, we select the next minimum weighted age. So then after 55, the next minimum weighted age is 66. So 66 will be connected. Sometimes here no cycle is formed. Don't confuse. This is not a cycle, and this is also not a cycle. Okay, so 66 is connected in the spanning tree. After 66, this vertex, all the vertices has been covered. Vertex number 6, 1, 2, 3, 5, 6, 7, 8, all the vertices has been covered. This is not a cycle, because we can fold it here, the 5, 2, 4 and 8. Okay, so there is no cycle in this minimum spanning tree. Okay, so this is the minimum spanning tree, and now the weight of the minimum spanning tree and the cost of minimum spanning tree will be the sum of all the edges which are included in minimum spanning tree, or which are shown in the red color. So it will be 23 plus 29 plus 31 plus 32 plus 47 plus 54 plus 66. It means 282. So this will be the weight or cost of this minimum spanning tree. So using Kruskal algorithm, we will find the minimum spanning tree in this way. Next one is the Prim's algorithm. How we can apply the Prim's algorithm on a given weighted graph to find the minimum spanning tree. So main concept of Prim's algorithm is that first we build a tree on a vertex, one vertex at a time. It means in case of Prim's algorithm, we select build the tree on vertex by vertex basis. Start with any vertex in the tree, okay. Then add the edge with minimum weight among those with one endpoint T in another which is not in tree. It means suppose this weighted graph is given, then at first we select any starting vertex and consider that vertex in minimum spanning tree. Now we will select the next vertex which is not included in current minimum spanning tree. Okay, it means in every selection a new vertex should be added on the basis of by selecting the minimum edge, weighted edge. Okay, so this is again the same graph, and now here we are going to apply the Prim's algorithm to find the minimum spanning tree. So let us consider our starting vertex is vertex number 1. Okay, vertex number 1. So vertex number 1. So we we will find the adjacent of vertex 1. So adjacent of vertex 1 are vertex number 6, vertex number 3 and vertex number 5. So 3 edges are there in the starting, 1 and 6, 1 and 3, 1 and 5. So among these 3 edges, the edge which has the minimum weight, that will be included in the minimum spanning tree. So among these 3 edges which connect to the vertex 1 and vertex 3, that has the minimum weight. So this edge will included in minimum spanning tree. Next again. Now 2 vertices are there in minimum spanning tree. First one is the vertex 1 and vertex 3. Now we will find the adjacent of vertex 3. Adjacent of vertex 3 is 1, 6, 5, 4, 2 and 7. 1 is already in the minimum spanning tree. So among 2 edges are remaining 54 and 80, and new edges are 75, 88, 55 and 23. So and 66. So among these edges, we will select the edge which has the minimum weight. So among these edges, edge 23 has the minimum weight. Okay, edge mean which connect to the vertex 3 and 5, that has the minimum weight. So this edge will included in the minimum spanning tree. So now these two edges are in the minimum spanning tree. Okay, so in every selection a new vertex is added. Initially we started from vertex 1, then when we select this, then vertex 3 is included. When we select this edge, then vertex 5 is included in minimum spanning tree. Again, now we will find the adjacent of weight is vertex 5. So adjacent is 2 and adjacent of vertex 5 is 7. It means 2 new edges we discovered here, this edge and this edge, and this is this one, these are from previous selection. So among these possible edges, we have to find the edge with minimum weight. So 80, 54, 75, 88, 55, 32, 66 and 93. So age with weight 32 is the minimum weighted age. It means age which connect to vertex number 5 and vertex number 2, that has the minimum weight. So now this age will be included in minimum spanning tree. Okay. So now by selecting this age, by adding this age to minimum spanning tree, a new vertex is included in the spanning tree, and that is the vertex 2. Okay. In the next step, we will find the adjacent of vertex 2. So the adjacent of vertex 2 are vertex 4, vertex 8 and vertex 7, 3 and 5. 5 is already included. So how much ages we have right now? Age number 80, 54, 75, 74, 88, 55, 31, 74, 66, 93. So among all these ages, the age which connect vertex 2 and 4, that has the minimum weight. So this age will be added to the minimum spanning tree because this has the minimum weight. Okay. So we will add this age. So by adding this age, a new vertex is included in the minimum spanning tree, that is vertex 4. Now how many vertex are remaining? Vertex 6 is remaining, 7 is remaining and 8 is remaining. So now in the next step, we will find the adjacent of vertex 4. So adjacent of vertex 4 are vertex 6 and the weight 74, vertex 3, 88, this is already included, and 20, vertex 8, 29. So now these ages are remaining, and among these ages, the age which connect to vertex 4 and vertex 8, that has the minimum weight. So now in this selection, this age will be, at this time, this age will be selected and it will be added to the minimum spanning tree. Okay, because this has the minimum weight. So age which connect to vertex 4 and 8, that will be selected and added to the minimum spanning tree. So this will be added. Now two vertex are remaining, vertex 6 and vertex 7. Again, we will find the adjacent of vertex 8. So adjacent of vertex 8 is vertex 2, vertex 4 and vertex 7. This age has weight 79, it will not be selected, and it will form a cycle also. This has the 68 and 7 is also not included in the tree. So among all the possible ages, this age will be selected which connect to the vertex 7 and vertex 8. So this age with the weight of 68 will be selected and it will be added to the minimum spanning tree. Okay, sorry, again this 54, this is also this age which connect to the vertex 1 and 6, this weight of this age is 54. So again, at first we will select this age. Okay, this age will be, before selecting this age will be selected. So this, because if weight is 68 and this weight is 54, 54 is remaining, is small. So this age will be added to the minimum spanning tree. So it is added to minimum spanning tree. 6. Now only one vertex is remaining, 7. And 7, if we connect 7 through 5, then weight is 99. And if we connect 7 through 2, then weight is 74. And if we connect 7 through 3, then weight is 66. If we connect 7 and 8, then weight is 68. So 93, 66, 74 and 68. So among these 4 ages, this is 93, 66, 74 and 68. So this age has the minimum weight because its value is 66. This will not be selected. This age has the weight 66, and this again not form a cycle. It is looking like a cycle, but it is not forming a cycle. We can fold it and put it here. Okay, so this age will be selected which connect to the vertex 3 and vertex 7, and this age will added to the minimum spanning tree. So this age will be selected. It is, again I am saying, it is not form a cycle. We can put it here and it. This is not a cycle. Okay, so the weight of minimum spanning tree will be 23 plus 29 plus 31 plus 32 plus 47 plus 54 plus 66, that is equal to 282. So in both algorithm, Rim's algorithm, the minimum spanning tree weight is also 282, and when we applied the Kruskal algorithm, then again the weight of minimum spanning tree is 282 and the minimum spanning tree is same. So in this way we apply the Prim's and Kruskal algorithm to find the minimum spanning tree on a given weighted graph. Okay, thank you.